All. Uh, how are you? This is Amitupreti, and our today's session is for electric dipole. Okay. Firstly, I want to ask that what is electric dipole? Electric dipole is nothing but two equal and opposite charges. Suppose one charge is minus q, another charge is plus q. Two equal and opposite charges separated by some distance. Suppose this distance is 2a for our convenience. So this arrangement of two equal and opposite charges which is separated by 2a distance is called electric dipole. In our daily life we come across such type of dipoles, like in chemistry you read about the molecular structure of like S2, like NH3. So these are the example of dipoles only, because here as well the opposite charges are separated by some distance. Okay, so I want to tell you about the electric dipole, that this electric dipole has a length, and this length is also a vector. It is denoted by 2a vector. The length of the dipole is denoted by 2a vector, and the direction of this vector is from negative to positive. Negative to positive, right? Here we are interested in taking out the electric field due to this dipole. Suppose somewhere at axial point or equatorial point. Okay, what do we mean by axial point and equatorial point? Now see, axial point means the line joining the two charges. This is the line joining the two charges, and the line joining the two charges is this one, like this, right? This one is the line joining the two charges, and if somewhere in the line joining the charge there is a point P, there is a point P on the line joining the two charge, and this point P is called the axial point, which is on the axis. Now here we want to know the electric field. Electric field due to the arrangement. Arrangement means the equal and opposite charges. For this we will assume that the midpoint is O, suppose, and the midpoint and this one point is A, this one point is B, where the charges are located. From the midpoint, the distance between the midpoint and the points where we have to find out the electric field is suppose R. This is the distance R. So what we are doing, we want to know electric field at axial point. We want to know the electric field at axial point. Now, what is the electric field here? Due to this and this, means the arrangement. So for this, we know the formula of electric field, obviously. But firstly, I want to just pay your attention toward the direction of electric field due to the charge minus q and due to the charge plus q. Firstly tell, due to the charge minus q, what should be the direction of electric field here at this point? Because a point is always considered as a positive point charge. So this positive will be attracted by this negative charge, and the electric field direction would be like this. This is EA, electric field due to A, due to this one. And now the electric field due to the plus Q charge. Can you tell the direction of electric field due to plus Q charge? Yes, it would be in this direction. So can you tell which one is bigger, EA or EB? Obviously, EB would be bigger. Why? Because the distance is smaller. So what is the distance between B and P? This is R minus A. And what is the distance between A and P? This is R plus A. Look, this is the distance. So obviously the distance, this one is smaller, so electric field is bigger. So EB vector is bigger, right? Now according to the law, EA magnitude is equal to, I am talking about the magnitude right now. Magnitude of EA is equal to 1 by 4 pi epsilon naught Q, because I am talking about the magnitude, so minus sign I will not take, upon R plus A whole square, right? Now tell me about EB. So EB is equal to 1 by 4 pi epsilon naught Q upon R minus A whole square. So EA and EB we have taken out, but we have to take out the net electric field E here. We have to take out the net electric field E. So can you tell me the direction of E? Of course, it would be the direction of the bigger vector. So bigger vector is this one. So this is the direction of E vector. And what is its magnitude? Magnitude of E would be the bigger vector minus the smaller vector. So it is equal to 1 by 4 pi epsilon naught Q upon R minus A whole square minus 1 by 4 pi epsilon naught Q upon R plus A whole square. Right. So what is E? 1 by 4 pi epsilon naught can be taken as common. 1 upon R minus A whole square minus 1 upon R plus A whole square, right? So E would be 1 by 4 pi epsilon naught. This is R square minus A square whole square. If we'll take the LCM, the multiplication of these two would be R square, R minus A into R plus A is R square minus A square, and square would be outside, right? So this is R plus A whole square here. So R square plus A square plus 2RA, and this would be R minus A whole square here. R square plus A square minus 2RA. Now electric field would be 1 by 4 pi epsilon naught. What would be cancelled? R square and R square cancelled, A square and A square cancelled, 2RA plus 2RA, minus and minus become plus. So 2RA plus 2RA, that is 4RA upon R square minus A square whole square. So electric field would be 1 by 4 pi epsilon naught. Okay, something is missing. Q is missing. Q taken outside. Q taken outside. Q. So Q into 2a. Right? So take it. Q into 2a into 2r. Like this you can write. Upon r square minus a square whole square. So which is equal to Q into 2a is P. I forgot to tell you that electric dipole moment is equal to either charge multiplied by the distance between them. Either charge multiplied by distance between them. Q into 2a. And obviously this is also a vector. And the vector electric dipole moment is same direction as the length of the electric dipole. Length of the electric dipole is from minus q to plus q. Same as the electric dipole moment q into 2a is always directed from minus q charge to plus q charge. Right? So this is 2pr. Right? This is q into 2a is p. This is p. So 2r into p. So 2pr divided by 4 pi epsilon naught r square minus a square whole square. R square minus a square whole square. Right? So r square minus a square whole square would be there. पानी की वजह से जरा इंक नहीं चल रही, तो आप इसे लिख लीजिएगा 2pr डिवाइड बाय 4 pi epsilon naught r square minus a square whole square. Thank you for watching.